All right. Look at this spiky guy or girl. Who knows what it is? It's a Bart Simpson haircut. All right. So let's look at this beast. What's my pattern on this one? I have like a little bump, big bump, right? So what's W's? Can you guys see this orange? Would you agree from here to here is one period? So what is that? 2, 6, 8. All right. Boom. This quiz next week's going to be so easy. I'm almost embarrassed to give it.
Actually?
No, absolutely not. Yes. All right. What's my amplitude of this beast? Hold on. Big question on this one. Am I going to do this one or this one? The biggest and the smallest. So what's this length right here? It's 7. And what's 7 divided by 2? Okay. It's too easy. If you go, you know what to do. Go. Mine's 100. You don't know what that's about, internet people. All my subscribers. What? I'm on video. I'm filming this right now. All right, what's my max values? What's my max? 4. What's my min? The grind don't stop, internet. Live stream. I should no. I gotta edit this out. This is too warm. Nope, no cap. All right. What intervals am I increasing? So let's take one of them, right? Would you agree I'm increasing from -2 to -1, right? Now, wait a second, though. Hold on, though. Hold on. I'm actually going to use brackets. But now, where else am I increasing? From 2 to 3. Now, wait a second. I want every single interval I'm increasing. So what do I do with those two intervals? It's -2 plus, what's my period? 8n. 2, -1 plus 8n with 2 plus 8n, 3 plus 8n. Because for whatever I plug in for n, it'll work, right? Well, I've put n exist. Do you guys see I was doing that in the videos? That's saying n is an integer, is an integer, right? So it works negative. It doesn't work for decimals. N has to be -1, -2, 0, 3. But for any value I plug in for n, this interval will work. And you always just take your interval and you add your period times n. N exists in the set of integers. Technically, that's actually an Algebra 2 concept. I'll make sure you guys get it.
You must have missed that.
It's only used in this. So this is your letter n exists as an integer. It is an integer. You could have also written, if you don't like that, you could write n is an integer. You could write that too. But do you guys remember, in Algebra 1 we do this. Capital Z means the set of integers. That is in Algebra 1. I know I teach Algebra 1. Yeah. Not well. All right. Where am I decreasing then? Everywhere else. So from -1 to 2. So I just start with -1 plus an. 2 plus an. Right? Do you guys see where I got -1 to 2? Where else am I decreasing? So I did this one, right? I need this one, right? 3 to 6. Now, could I have picked a different interval and done that? Yeah, it doesn't matter because n is an oopsie integer. I could do that too. Oi caramba! Ooh, eep, eep. Do you guys know how to find? Do you guys remember average rate of change? Average rate of change is your f of b minus f of a over b minus a, also known as slope. Find the slope between those two intervals. What did we call it? We used to call it AROC, right? Average rate of change. This is from unit 1, like section 2 or something like that. So what's my average rate of change from 2 to 3? What's my slope from 2 to 3? How much did I go up? How much did I go over? So my slope is 7 there, right? I went up 7 over 1. From 3 to 6, I go down 7 over 3. Negative or positive? Negative. So my slope's negative 7/3. And then from 6 to 7, how much do I go up? 5 over 1. So 5 over 1. And then 7 to 10, I go down 5 over 3. Does that kind of ring a bell? Yeah. Slope, right? Average rate of change is the slope. Slope is your average rate of change. Whew. One problem done. All right. Any questions on that beast? All right, good. Good. That's a lot. That's a good review. I like that. No, we got 2 more to do. Oh, mama. Look at this beast. A storm siren makes 2 rotations per minute, and the sound waves have a radius of 1 mile. Their house is located 1 mile south of the siren. The distance of the sound wave to his house is periodic. So, why? You guys know Doppler effect and stuff like that? Like, you guys all took physics, right? Have you ever heard like the old police sirens like, wow, 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 right? That's because their noise is spinning and you're hearing it go, it's really loud when it's facing you and then it goes away and it whips back. That's Doppler effect. And it's like, if you are at a NASCAR race, it's like, vroom, vroom, right? That's how a lot of storm sirens, old ones, would work, is they actually had a rotational thing. Now they just have like 3 things that just shoot them out. But that's where that wah, wah, wah comes from, right? So now we're getting to real life stuff. I like it. Wah, yeah, that's where wah, 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 wah. So 2.5 rotations per minute. So how long does 1 rotation take? What's my period in seconds? So I'm looking for 1 rotation. If it's 2.5 rotations per minute, I'm going to do 60 seconds divided by 2.5, right? And you'll never guess it. It's 24 seconds. I took time divided by rotations to get how long is 1 rotation. This is where things get a little wild. Now let's think about this. It's a mile radius, right? Agree? So let's start it. If the siren is shooting sound a mile this way and their house is a mile this way, How far away is the sound from the house? So I'm going to start here at 2 miles. Sound good? Now it's going to start here. When's it going to be right at that house? That's a half rotation, right? How many seconds is a half rotation? So at 12 seconds, what's the distance from the sound to the house? 0. Because now the sound is a mile south and the house is a mile south. Does that make sense? And then where's it going to be in 12 more seconds? At 2. Once I had that graphed, one full rotation, I just repeat it, right? So every 24, it's going to repeat, right? Every 24 seconds. So now I can graph my wave. Now, did I have to do this picture to graph it? No. My amplitude is 1, right? Because it's a mile. But then this would have been my midline, right? So I would have went a mile up, down, and then it's 24-second period. I like to think about what's actually happening, though. That helps me graph it. You know what I mean? Could I have started at 0 and done the same graph? Yeah, you could have. So, like, be careful when you're grading yourself on these. If yours would have been like this, whatever. It's fine. Like, you're fine. You know what I mean? Like, don't graph it better than that. Be better than Mr. Twilliger. Oh, never mind. You can't because it says this. I'm kidding. And we're done. Yep. So we have to start it when it's facing north. Draw pictures, guys. When we're getting into real world stuff, I cannot emphasize enough how important it is to draw diagrams and such. All right. We got one more. Ooh, a Ferris wheel. Oh. Sorry, people. You guys have a paper, right? People on the internet, you can pause and read it. You guys can't see the screen on the internet. This is just for people with a packet. I'm not going to lie. We'll find out some stuff. I'll write on the side. So there's a Ferris wheel. I'm going to draw the Ferris wheel. It's 120 meters in diameter, so that's all the way across, right? It takes 30 minutes for one rotation. So right away, what's my period going to be? No, guys, it already tells you it's 30 minutes for one revolution. So it's 30 minutes per one revolution. It's just 30. You know what I mean? Because your height's 0, and then 30 minutes later it's going to be 0, and 30 minutes later, yeah, I did. I'm like, don't overthink. The other one gave us 2.5 revolutions in a minute, right? This one tells us it's 30 minutes is one revolution. Like, we know exactly how long it takes for one. So we're going to call this height 0. And what would this height be up here? 120. So what's my amplitude going to be? 60. Yeah. Because my whole height is 120. And I'm going to divide that by 2 to get 60 is going to be my amplitude. Oh, we can actually do C right now too. Well, I'm going to do C right now. How long is it going to take to reach 120 feet? 15 minutes, because it's half of the time, right? See, that's not. Again, drawing the picture really helps, right? I'm going to draw the picture. Yeah. Let's make our life a little bit easier when we go to graph it. So at time 0, we're going to be at 0 height. Do you agree on that?
Yes.
At time 15, we're going to be at 120. Do you agree on that? What's this time right here? 7.5, right? How high are we going to be at 7.5? 60. And then this time it's going to be half of it. So how high are we going to be at 22.5? 60, right? Do you guys kind of see what I did there? I labeled it. So now when I go graph it, I have those points, right? And then they're just going to repeat. Let's see if I was right. So I start at 0. Oh, whoa. I start at 0, 0. Get my peeps on. I'm going to go to 7.5, 60, right? $15, 120. And then 22.5, 60, right? And then where am I going to be at 30 minutes? Back down to 0. And if I had to graph this again, I'd just keep adding 30 to each point, right? Move it over. So it's going to look like, try to make them look smooth. You know what I mean? We're starting to get to the point. They're going to look like bell curves. All right. That's what I got. That is roll. It is. All right. That's it. That's all I got.